In this video, let's try to do these two questions. And before that, let's take a look of what pulley is in case you don't know. So I think in the earlier video, I have shown you already that pulley is a simple device where you can pass through a rope onto it. And basically here is a wheel where you can turn it freely without friction. Of course, in reality, there must be a little bit of friction, but an ideal pulley, there will be no friction when you turn, and the rope can hold on to it, of course. And so there are some system like these kind you may get to learn in a more advanced physics, and in IB we only learn the simple form as in one pulley only. So like what you do, maybe when you saw some people in the gym, you simply just pull this down and then you can lift the mass on the other side of the pulley up in that case. Or if you have two masses like this and you release it, of course the heavier one will go down and the lighter one will go up. So this is some background information. Let's try to do these two questions. Again, you should draw the free body diagram first. Try it out and we'll check the answers later. Okay, so let's take a look of the first question. There are two masses, 4 and 6 kg. Again, they are joined by a pulley. So of course, for the actual pulley, they should have a certain way to fix, or maybe the ceiling or somewhere, a fixture or something. You don't actually need to care here. And there's a rope or string somehow vertically hand them up. So 4 and 6. Doesn't really matter the height which they started with. The question also tells you that they were held in stationary at rest, and in this question it doesn't really matter. Held at rest would be quite important when they are of the same mass. So for example, if they are not 4 and 6, let's say they are 5 and 5, then the configuration, whether it is at rest or what, will be more important. While for if it is the case 4 and 6, then not really much, because at the end the acceleration would be the same, and it will be just easier to calculate. And then for what happened next is they would be released later on very quickly. They want you to calculate the acceleration of each mass. So similar to the previous video, that example, since they are connected by a rope that is inelastic and massless, then the acceleration, or you can firstly think about the displacement of each of them will be the same, because if these move down by 3 cm for a certain time, then the 6 kg, that one will also be moving up by the same distance, 3 cm. So they must have the same velocity and acceleration in terms of magnitude. Why would I say magnitude? Because obviously they are moving in opposite direction. 4, that one will move down, 6, that one will move up. So if you're saying A4 equals to A6, then you're wrong. You have to say maybe one of them as in negative, because they are in the opposite direction. So let's define the direction first. So if I say upward is positive, then I guess it's fine. Then A6 is positive value and A4 is a negative value. And then what we can do next is to draw the free body diagram for each of them. So box 6 and box 4, and each of them will have its own weight and also tension. So for tension, some of you may think, hey, would they have the same tension or different tension? And once again, because of the string itself, it is massless, then the tension would be the same in that case. So if you're okay with that, then we can start off with the equation F equals to ma for each of them. So maybe I'll write the 6 that one here to save some space. So since we take upward as positive, so we have T minus W4 equals to 4A4. And for the 6 that case, actually it will be very similar, 6A6. Okay, and then we can try to write one more steps. Actually it will be 40 for the weight if we take G as 10. And then for A for this one, we can actually change it to A6 by putting a negative to it. And so then we can kind of eliminate one of the unknown. And here we can keep it as 60 and keep it as A6. So we have two equation 1 and equation 2. And by looking at these, and since you want to find the acceleration, then you want to get rid of the tension. So the easier way to do probably should be 1 minus 2. So the left hand side minus the left hand side, right hand side minus right hand side for each of them. So that will be t minus 60 minus the t negative 40, and then equals to 6a6 minus the negative 4a6. So in that case, both t will cancel out, then you have negative 20, and you would have 10 times a6, and eventually get a6 equals to negative 2 meter per second. Oh, I just find out I said something silly at the beginning. 4 that one will move down, 6 that one will move up. So if you're saying
4 that one will move down, 6 that one will move up. So if you're saying
well, the reason why it is negative is because by its nature, the 6 kg that box will actually move down. I don't know why. Maybe I was distracted. Actually, this will move down, while the 4 kg that one will actually move up. Alright, I don't know why I was so silly. But then physics save us, right? I mean, save me. That eventually I find is negative 2. And because of the definition of the direction, I said upward is positive, and I find A6 is negative 2. So it actually tells me that it's actually going down instead. Okay, so apparently for the 4 kg that one, then by using this relationship, because this one still hold no matter what I take, because they really move in opposite direction. So you may find it is positive 2 meter per second square for the acceleration. Okay, so let's move on to the next question. Try it out and pause the video now.
A few moments later.
Okay, so in this question, they already help us to draw the free body diagram separately like this. And notice that one of them is the big M, the other one is a small m hanging outside. And there's also no friction as well. So for formulating the formula, let's start with F equals to ma again. And for the big one, I would actually have only tension T, and it will be big M times the A. Again, they both have the same magnitude of acceleration. So you may wonder, so what's wrong with the direction then? Like how do we set? Doesn't really matter if you only want to find the magnitude. And from the diagram, you can tell the direction quite easily. And so this is for the big mass, and for the smaller mass, you would have vertically, because apparently, okay, this time I won't make it wrong, it will be moving down for sure. So maybe let's take the downward as positive in this case. Then we will also have F equals to ma, and downward as small mg minus the T equals to ma. So when you have these two equations, then you will be able to find the expression for each of them easily. So if I say this is equation 1, this is equation 2, then I'll simply substitute 1 into 2. Let me write down sub 1 into 2, and then you can have mg minus big ma equals to small ma. So you would have mg, small mg equals to big ma plus small ma. So if you try to express the acceleration, again they have the same magnitude of acceleration, it will be small mg over big M plus this small m. And so if you really want to express, because the question also tells us to find the expression for tangent, right? So we can substitute the answer back to equation 1. So tangent will equals to the big M times the one that we find for A small m g over big M plus small m. So that will simply be the expression. You can't do anything else because they didn't give you any number. However, out of the answer of this one and this one, we can see a little bit more as a physicist. And that is, what if we have the value of big M much bigger than the small m in that case. And by looking at all these things, especially for acceleration, then you can tell if say this is big M is much bigger than small m, then you can simply think about if big M is say 1000 and small m is 1, you can think about substituting into the equation here, and what you get will be A equals to, cause small m is like very small, right? And then times G over about 1000, so maybe this is 1 and this is 1001. So pretty much you can say m is like 0. Okay, so at the end of the day, you have a number that is extremely small, even if you multiply with G. And for more extreme case, you may imagine m is like infinite kg and m is like 0.0001, something like that, or even 0. So in that case, at the end you have a very small m, which basically tends to 0 times G is already 0, while the big M at the bottom will kind of make the whole fraction even smaller. So at the end, the acceleration will be 0. So this is the interpretation from the mathematical way. And if you try to look into the actual scenario using the intuitive sense, you can also tell if this mass is extremely heavy, while this one is like nothing. Like imagine this is like a mountain and this is like feather, then of course no matter how the feather try to pull, the mountain will not be moving at all. A similar case can also be thought as in the small m is actually much bigger than the big M. Okay, the notation, lowercase or capitalized, is just a notation, right? But then let's just say the small m is much bigger. So small m is like 9,000 or 1,000, while the big M is like 1 kg. Or again, to more extreme, the small m is like infinite, while the big M is like nothing, 0 kg. And by again looking at the mathematics of the formula of the acceleration, you will find A equals to like infinite. Okay, I know mathematics teacher would hate me doing that, but then I'm just trying to illustrate to you. So infinite times G over infinite plus 0. So you again, this is totally wrong in math, but this can help you to understand more physically what it means here. So these two kind of cancel out. Okay, again, don't do it in maths. At the end, leaving you with G. So that means in this situation, then acceleration of the whole system will be similar to having G, which is free falling, 9.81 meter per second squared. And if you again put this mathematical sense into physical point of view in the picture using simply intuitive sense, then you can tell if this big M is like 0 kg, so basically it's like non-existent, while this one is like infinite kg, then what simply happen is this one will simply pull like free fall by itself, because the only weight, alright, would basically dominating the whole system, and free falling is basically what you get in that case. So I hope you understand the reason why sometimes, actually most of the time, physicists other than different from engineer would use some actual numbers to calculate, but for a good physicist, we usually like to use a more general variable like what we do here. There's nothing that we have given number like m and also tangent, etc. There's no exact number at all, but then doing that we can derive an equation, and from the equation we can see much more, and this is what physicists like to do and help us to predict so many things. This may be difficult at the first place when you start to learn IB physics or physics in general, but at the end you will find the beauty of doing this later on, when this formula you derive can help you to observe the beauty of the universe.